Hallo Nishkal. No, I'm not using Caddy. I need to know A first. Why cosine is plus y sine thing is actually this. Oh, I have no idea why the simplify is not working. When you try that on this. I'm also not sure if you have a sec. I'm not even sure if we have a y. So what is this y here? That is the original p beta y coordinate, isn't it? So this one, 0.75. See if I have a sec. No sec. Sec is wanneer waren het beide sinus, I think. This is y times cosine plus sine squared divided by the cosine. So if you divide by the cosine outside of it, Then you get cosine squared plus sine squared, which is 1. So it's y divided by the cosine. So sec is 1 divided by the cosine. What? I really thought it was the other way around. I did ask ChatGPT yesterday, or wherever that is. Oh, yeah. Yeah, sec is 1 divided by the cosine. And then that's the numerator. So now we have to divide that by this expression here, which can also be simplified. That's kind of like I just took these terms, and you get that. I think this plus that or something. So I took x squared cosine squared plus 2xy cosine sine plus y squared sine squared, which is yeah, that. Can I copy that? Type it over. X cosine plus y times the sine, and then all of that squared. Square but I didn't use these two yet. Minus x cosine squared minus y cosine times sine. And minus x cosine squared minus y cosine sine, which is then this. So I could do minus cosine theta times, again, the same expression. Maybe I should use a new variable for that. Let's call that z times z. Z is that. Right, x cosine plus y sine. X cosine plus y sine. So then you can just do z times z. Z times z minus cosine times z. I don't know, let's put more brackets around it. I don't know. Let's multiply the cosine here as well in. So times cosine. So I can remove it here. This better work, otherwise I have to check for errors and stuff. Now I want to create a curve. I don't know, I equals we think yeah, that's the range of x actually. Double x is, what the hell is that? Minus 1 to 2. That should be good enough. That's more range here. Minus 1 to 2.0 in maybe I don't know, 100 steps ish. This one takes 80 steps. So I'm gonna do 0.05. Yeah, I already have an x. Let's call this a loop x. And the loop y is then equal to a times lx plus b times lx and then I want to make a curve 2 points dot push back and just have x and y and place back loop x loop y. Well, this is again a vector of points, right? And then we have to plot that as well. Give it a red color. Now, hopefully that works. I doubt that. I mean, how can this work like the first time? Impossible. I have no idea what's going to happen. We don't get to see anything. Nothing is red at all. Nope. No curve. Oh, that's pretty annoying. So let's make it equal to Lx. That should show me something. Still nothing. Should be a line, right? Like so. A line, this line here. X equals y. Oh no. We see the error, yes. LX. It didn't loop at all. No, first want to see the line. I'll remind you and cipher full. There's our red line. Now let's change it back to the heavily mathematical curve to calculate it. Yeah. Hit in one. I did not make a mistake? You gotta be kidding me. Well, proud of myself. You know what I'm also proud of? You know, I grew up in a city, the north of a big city, 100,000 people. And then I moved to another city 100 kilometers away, and then I moved to another city where I lived 25 years. And then I moved to another city where I live now. And then I met an old woman of 85. And she's new on the club on Mondays. So, I don't know, there's new members, you know. And I said, I think I know her, you know. So last week I saw her for the first time, and just pure on face, I said, don't I know you? But yeah, we couldn't find anything. So this week I was thinking, and I thought, yeah, really, I'm sure I know her. It must have been from my youth. So today I asked again. I think I know you. I think I know you from 45 years ago. Do you know my parents? And yes, I did remember her. And when she said her name and stuff, I even remembered more. That I visited their house, how old I was, how their house looked. They had built it themselves. I don't know. And I'm complaining about my memory. But yeah, I mean, maybe it's really dementia then coming up. I suppose you keep your memory from the past. Well, it still gave me a good feeling that I actually managed to do that. See this, man. This red parabola is going through P0, P1, and P beta. Yeah, I used to have a special memory. Did I ever tell that on the stream? Maybe I did. I probably did, actually. But now I have other viewers. So at one point, also in my youth, I think I was like 15, between 15 and I don't know, 22 or so. I was a radio pirate. An electronics hobby. I built a transmitter, and then I was just transmitting on the radio, talking with friends. We used to do that, you know, on the normal FM radio. They didn't have. They were at different times, so lots of people still had antennas and everything. And so I was talking with a friend over the radio while laying in bed, and I had several, how do you call that in English? Let's just say years of Donald Ducks, if that's also the English word or not. And he said he did that too. He had a several year I know jaargang in Dutch. I don't know what it is. So I told him, well, okay, you know, let's do the following thing. You pick a random Donald Duck magazine, open it on a random page, and read the text balloon. And I still to this day know what he was reading, and then what was on that page, what was on the picture. So he picked from the many things he had. He picked a random one. He opened it and he said, so in Dutch they call quick quack and quack the young ducks that live with Donald. And they were saying, if we go down here, we take a shortcut. And I just saw the image. So I said, yeah, they are going down a garbage dump. And in the middle you see a wooden thing with 2 wheels on it, a big one and a small one with a snare around it. And the text, Atlas vermorzelt alles. So in English that is, Atlas, I don't know, destroys everything. I just knew the whole image. It's amazing. But yeah, then again, you know, in the past, my memory was like, name anything, and I would see pictures of it if I wanted to, at high speed, of say every time I saw that in a movie. For example, a red car. And I would see just red cars from ding, 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 ding. All the red cars I ever saw in movies. And then had the feeling that I would be able to continue with that forever. At some point, I just stopped my mind and then stopped doing it. And now, it's for decades already, it's just a blank. I cannot remember anything anymore. You name anything and I can't remember it, really. It's sad. Okay, but this works. Woo! And now it disappears. Why did it disappear? Well, it's not possible to draw a parabola through this one and through that one. I bet this one is on the left, I guess, of this. So when are we going to pick it up again? Oh, now it's back. Maybe there was just a problem with being completely vertical. Yeah, that was a problem. So I just couldn't draw it. No, this one also not, of course. Now P0 and P1 are vertical. And then I turned it upside down. It just works perfectly. Yep. Beautiful. Now you gotta wonder, what the hell is this doing? Why is it like this? I suppose, I mean, I have the rotation right. Do I not? I think I have to convert this red parabola to the parameters or variables used for the generation of this one. Compare them. This, though, is for a t value that is not negative. So we have to still, so it's larger than 1 here, the t value, and now it's negative. So this would be a solution where the beta comes before P0 and then we get P1, if you travel over it like that. Now imagine we have another point that is, well, here, for example. Then of course the red one would be, you know, going through 4 points. That other point is also connected to the coordinate system connected to these points, so they just rotate all three. So I would rather put this one. Yeah, I want to have the vertex in between P0 and P1, because that's where we should be doing. So for example this one, but let's put P0 of P1 on the other side, the coordinates. I'm gonna so ignore that. No, this, no, not this. Yeah, I want P1 on the other side. Don't call him again. So this would be good. No, the vertex is still not in the right place. Now it's good. This is what I want to see. So first we have P beta, and then we get P0, and then we get P1, and the vertex is in between P0 and P1. There would be a possible curve fit, so. And then there is still a possibility to have some variation for a fourth point, or am I mistaken here? I think there is. So now it's, I have to rotate this thing back, I think. So P0 and P1 are again horizontal. Which means I have to convert the red parabola, which is just y is a function of x, back to the parametric representation. That seems to be the correct next step. Oh yeah. Yeah. Wish you could rotate back. You see now the red line is in the what's the English word? In the whatever, the extension of the P0, P1 line. Het verlengde van. Hey, I know the Dutch word at least. And if I rotate this thing further clockwise, then the red line that emerges from P1 is going to go that way. So it's this quadrant, this area here, where we can have a fourth point. And then pick it. For example, this is length 1. So suppose we go, after this, we go under 45 degrees, a length and a half. That would be about there, right? So if there is a point here, and I step one further, so now that point would be there. So we step further. Now the point would be 45 degrees, so there. And now there. And now there. Maybe flip. There-ish. There. About there. So now it would hit. Because this red line, it was in the same direction as this line at first. So it rotates and it sweeps this quadrant all the way until it is perpendicular to this line almost. So the fourth point will give me the exact solution. We try to convert this back to a parametric thing. Yep. So I know A and B. And that then is equal to equal to what? I'll have the same thing here. Is not trivial. Just type it out. Whatever. So we have x of t equals t times m0, which is this. Let's remove the std. And say t times m0 plus m01, which is that, times t, or we can write that as that. That's this, yeah, no, that's xt. And the other one, yt, is t times m10, which is that one, plus m11 times t. Yeah, I think I got that right. T times one zero is minus that plus t times this one, yeah. And that looks like it can be written a little bit more on this one too, probably, yeah. Let's take the sinus outside of it. This is the sinus times that thing divided by, and then here as well. Yeah, actually the r is reciprocal of the square of w, if that is correct at all. And then we end up with a 1 minus t. And since this is math, I might as well remove that 0.0. And here we have something very much like it. This is just t times, and then we have that thing times, and then this becomes minus 1, and the other thing becomes t. No, t minus 1. No. Okay. Yeah. I guess I would like to. I'm just gonna make this a minus sign. I think. No, wait. Yeah. Well, actually, I am. Did I do that correctly? I have no clue. Anyway, I make this a minus sign, assuming that it's correct. We get here t minus 1 as well. Yeah, well, whatever. And now I have to solve t from t from one of them. Uh-oh. Oh. This should be a simple y is a function of x. It should be. So if t is 0, this is 0, and if t is 1, then x should be 1 and y should be 0. Well, definitely y is 0. And this is, yeah, if t is 1, then this part is 0, and this is a 1 times 1 is 1. So far, so good. No. Okay, so we fill in, let me see, well, x, I could fill in x beta. Just copy it, but then label everything with beta. That should be on the curve. Y beta equals t beta times that. Which gives us I might as well do it manually instead of asking, you know, ChatGPT or Mathematica, because that takes forever. So we have to write this one out after all as a polynomial in t beta. So that is t beta times 1. Wait a minute. This is not a function of. I'm just scared I made a mistake, you know. All those little steps. Yeah. So far, I didn't make a mistake, so let's just go over it. Wasting a lot of time if I did make a mistake. So this is kind of like, this is a vector. And then we multiply that with t beta times t beta, which then is t beta squared, plus, well, minus, but that times a minus 1 times the t beta here. Let's just subtract the x beta from it on both sides, and then this equals 0. From which we can conclude that t beta is equal to maybe I should divide left and right by this factor. Gives a more complex c value here, but the rest becomes simpler. A lot simpler. I'm just going to assume that this is not equal to 1. It's not that important, I think. So we divide by that. I get this squared minus that minus x beta divided by this whole thing. I'm missing a bloody okay, I did something wrong. Shit. No, I have to start over. I'm going to start over. I don't like errors. So you have t times m0, which is 1 plus rsw times the sinus. I don't know now why there's a minus here. But probably because, you know, but nobody knows. Too many simplifications. Okay, now by this time it would have been faster to do this with Mathematica. If I knew how, you know, certainly if I knew how, then it would have been faster. Okay, let's do that too. Let's use Mathematica. At least then we don't have those errors. It also takes time, but making an error makes also costs time. I'm just gonna go for a completely new. Oh. Click. Click. Top, and then make it Mathematica-ish. I think this star we can keep. So to check, please bounce my M00 back. No, I'm not sure it knows what RSW is, so let's put something in front of this. Oops. Symbol name maybe? RSW. And while I'm at it, whoops, I keep pressing that button. Symbol name theta. Shift enter. And now the output is, oh, that's just for the first two lines, and now we can do this one again. No, still looks the same. M01 is that one, where this is and the next one. Also convert. Oops. Ctrl C, extra colon, return, and then this one. And actually I want everything in one thing because it keeps forgetting it, and then I have to repeat it. So I might as well put everything in one, whatever it is called. That looks good, but let's copy this and then put that in front of here. Yeah, and then we have, for example, M11 defined. Oh, there it is. And then what I want to do was define these things. You could make that a function. This is also a function. But I'd say xt is this. And yt is that one. Okay, also defined. Can I now ask for xt, for example? Now we get the whole thing. Very cool. And then I want to know. Let's add some symbol names, just in case. So we have a symbol name X and symbol name Y. And then I want to so my X and Y that is my X beta and Y beta. And now I want to solve, which is then the T beta. And I started at start with the first one. So I want to solve T from setting X equal to this expression, and which is the xt. So we want to solve xt equals X and then get T. Yeah, I hate it. There are two solutions, really. Oh boy. And then we have to fill that into the Y. And then solve for RSW. Don't we? Bet it's gonna be a 4th degree polynomial again. Or worse. let's try it. If I know how. I think I first have to make a function. Let's say, if you enter solutions, put that in source, and then well, I'm not sure how to do that. Can you do YT? So if I now just do YT, shift enter, then we get back the definition that I put in here. And then what happens if I do slash dot and then say solves the first one? Well, it used it. Guess it used it. I think it put this thing in place of T, right? Because, well, there's no T anymore in here, so that's probably what it did. And now we want to solve our well, there's even an X in it still, but that's a constant, X and a Y. Why do I not see a Y? Yeah, I just have this. I have to set this equal to Y. So we have to do something like solve and then Y equals that last expression. I think I can use percentage. And then solve RSW from that. Oh, really? I was thinking it was a short result, but no way. There may be values of the parameters for which some or all solutions are not valid. So, kind of gave me a solution here that is looking surprisingly simple. The square root's a gun, 1. It even looks a lot like what I had before. So again, there's there's a y squared, not times something. There's an x time cotangent, I guess, cotangents squared. And then plus 2xy, sorry, well, same thing. So it's basically y plus x, the cotangents, whatever, squared. And then we have yeah, well, I don't know. Looks a lot more or less the same. Well, the same not, but kind of the same structure as we had before for A. Interesting, especially since A is supposed to be 1 divided this squared. I don't think so. Could it be? That would be shocking, to say the least. No, it's not. Or is it? No, it's not. It's not a reciprocal anyway. I don't know what this is. Nah. Okay, I'm gonna stuck now. It's hard to explain what I'm doing. Hey, hi Jess. And I do computers, Mr. Hello now. What am I doing? I ask myself that every day. I think this is linear in T. Not sure I'm on the right track, or I'm what I just did. Can't I just rotate this thing back? Let's try that instead. So I have, I'm not sure that this is correct. Let me just wipe it out. Calculate an A and a B here that apparently are correct. And then we have a parabola, a x squared plus bx. And now I want to rotate that anti-clockwise over an angle of theta again, which then makes it not a function anymore. So we need to have a parameterized thing. So you have an Lx is equal to, yeah, some constant times t. That must be correct. Must be correct, man. It is correct, I think, because, well, first of all, it goes through the point 0, 0 at t equals 0. So if t equals 0, then the x-coordinate is 0. So it is not plus some constant. And it's also, it has never been a function of t squared if the parabola is not rotated. And it is not rotated in this case. And then it is just linear with t. So I think this is correct, right? Just linear with t. And then we can fill that in for Ly. And now we have a parametric equation. It's a really lame way to get it, but hey. So fill that in. Replace Lx with Ct. And now we have x and y again as function of t. And now we can rotate it back the usual way. I would say, let's say, parametric equations for the parabola rotated back anti-clockwise. Not theta radians. Which end would be, I'm just gonna call it xt equals, so that would be the cosine of theta times Lx. That must be a minus sinus theta times Ly. Yt equals yeah, it's sine, right? Sinus of theta times Lx plus the cosine theta times Ly. And then the question is, what is C? I won't edit this, so we know where it came from. So this means that we can fill in Lx, which was C times T. And Ly, which is this thing. And then we can fill in A and B. Not that I really want to do that. I guess I can deduce C from. I think I can deduce C from the fact that if t is equals 1, then this must be equal to 1, and this must be equal to 0. I don't know. Let's draw it, maybe. Maybe that will give me more insight. Actually, I think I know what C is. If t is 1, then this must be equal to 1 rotated theta clockwise, which is the cosine. So C must be equal to the cosine of theta. Yeah. I'm gonna replace C with the cosine of theta, I think. Because I think that is correct. Do you think this would simplify if we fill everything in? Does this thing still know what A and B are is? Did I even fill that in? I don't think I did. No, we don't have an A and a B here. No, this is something else. Oops. Well, on top. What was the other one? You can go back or not. This one maybe? That was the last one, I guess. This one. And it looks old. Maybe that one. No, give up. Just type it in anew. Yeah, type it in. Type it in. Again, seriously, I remember vividly that I did all this before. Seriously. I'm getting pissed off. Like that's going to work, right? Probably not. Oh, look, there's only one sinus. Man, I could have done that one manually. But what about the cosine? The cosine and the cosine. Look, and then the tangents. Ton is the last one. Ton. Yep. And then I'll do this manually one by one. And then I have to copy this. Here, let's get rid of that. While I'm at it, let's add the symbol name. We have a Z and X and Y and theta. Is that not all? X and Y and Z. Random order. And theta. And I added one too many apparently. Yep. And yeah, same thing here. It is 6, but it is true. We don't have a tangent, I think. I have a cosine and a sine, I guess. That's a good tangent, cosine, sine with a G. Yep, I forgot the G. There's 2 cosines here. Well, then we do that like that. Oh, that's not a symbol name. Oh, wake up. Clear all. Alt top. Do I want to do this one now? And this one. Yeah. Doable. Cannot imagine it cannot be simplified though. Let's try that. I'm not that impressed by the simplify things. Nah, okay. This definitely looked better than what it was before. Yeah, I wish I would use Z instead. That one's a bit vague. Nah, okay. And the other one, full simplify YT. Not bad, bad. I'm gonna have to type that over, I'm afraid. I don't know how to copy that. Copy the clipboard, yeah. I don't think that works. I doubt it, but hey, paste. Nope, that's definitely not it. Let's replace this with another thing where we loop from, well, we loop over the new key, and it should always work if you do the same thing as above. Shouldn't it? That runs from -4, well, okay. Ish, and then the V, but who cares? T is less than 4. T plus is 0.1. And then we calculate. that. Right. Now, there we go. T times x minus 1. So t times the whole bloody thing, right? So we need another parenthesis. X times 1, I think this is another x there. Times the cosine of theta, I'm going to abbreviate that with CT. Squared. T times x minus 1 times x times square of the cosine. Minus t minus 2 times x times y. Which y is that? So the same y and the same y and x that we use here, I think. They just make their way through this. So that means they are actually called x and y. Okay. So we're here. Times y times the cosine of theta. Times the sine of theta plus y times y times the sine of theta times the sine of theta. This can be simplified. It can be simplified. Divided by, and then we get something times something. Let's do something times something. Where seriously, the last something is just a z. X cosine plus y sine. X cosine plus y sine. No, that's just z. So going to use z here. And this is the same thing-ish, except that there's minus cosine. No, it's plus. So it's x times cosine plus y sine, which is z, minus cosine. So this is z minus cosine. Why am I looking here instead of there? But it is the same. Okay, so that was this x. Okay, t x1 times x times cosine squared minus t minus 2x times y times cosine times sine plus y squared times sine squared. And there's also a z hidden in here, because this is y times there's an x that I'm missing. No, I could use this x. No, I could use this x. Okay, forget it. Let's keep it like this. Maybe I should not be using the z at all anyway. Semicolon. Double Ly is this one, right? 2t minus 1 times t times y times cosine of theta times cosine of theta, and then divided by the same thing as above. Of course, those were really the same. So that would be that. And then we're going to draw that, meaning this line here. No, everything is wrong, but we have something we can compile. Might as well try that. Oh no, undeclared cosine of theta. Double cosine of theta is the standard cosine of theta. And the sine of theta is the a blocky thing, but it does hit P0, P1, and I think it's the other one. No, I commented it out. It's just fucking going through all 3 points. Wow. It's a bit too blocky though. Let's make small steps. Yeah, this one. Beautiful, straight through it. Now the problem is that if I start rotating stuff, then everything still rotates. I mean, you can ignore this one, it's just bullshit. But P0 and P1 rotate. And then what I did was calculate a red parabola through it. So we say P1 rotates this way. Then of course the parabola becomes narrower, kind of like that. And then I rotate the parabola back. So I think that... What the hell should happen? I think it should still go through these points. Yeah. No, because I know I'm rotating the point. So apart from this one, it should still go through 0, 0. That P0 that doesn't even move. But it should go through 1, 0. And the parabola should rotate this way. Ta-da! And it does. How amazing is that? Yeah, so the parabola rotates this way and goes through 1, 0. And it does not go through P beta because I rotated P beta away and I also rotated P1. So we should not do that, otherwise we can't see it. So I should stop rotating P1 and P beta for this image. Where is it? The rotation. Yeah, rotated P1. So maybe I should just comment it out, or let's see where I use it. I think I'm only using it to, I'm not only using it, I'm actually using it here as well. Yeah, why did I call it rotated P1? I know I have to change it back, and then I forget where. Yeah, rotated or not rotated, is that the question? I think I'll leave the name, even though it's now no longer rotated. So I'm just setting it equal to P1. And then the beta thing, P beta here. We also have a rotated P beta, so same thing there. I just set this equal to be a P beta, which means that it's not rotated. I don't think this is being used anywhere else than on these lines. So no. Aren't you guys amazed that it just works? Like, I mean, I typed those horrible formulas in and no errors. Seems I never make errors. It's scared, even scares myself. But yeah, so that worked. Bang. This rotated parabola now goes through P0, P beta still, and P1. So I just rotated it back. And now the question is, can I create another point? Because, yeah, this, if there was a point here, then that would belong to, come on. You know, normally you just zoom in on a curve such that these things are like almost linear. So P beta should be like here, or maybe then there, and then this is a parabola that you want to look at. That's ridiculous. I should move it somewhere else, I guess, to be more realistic. Let's move P beta to a half, a quarter. Yeah, or what did I say? A half? I meant minus a half, I suppose. And then this was plus a quarter. Was it? Was it? Perfect. You would almost not rotate it, if you get what I mean. And I probably should suppress this one because, well, this one is just the old one and this one is better. This one goes through actually through P beta. No more need for the other curve. Kill the other curve. I don't think I need a V, and we don't need anything here. Go away. And then we still have a variable left. And now we have a parabola that goes through 3 points. Except, of course, when it doesn't, but that's probably for a reason. It's beautiful. We have left off for 3 points. And then the big question is, the other tail, well, sometimes this tail goes through here, but like I said, real data points are going to be like on a parabola in this direction. This is close, this is also close. It's almost linear. So if it's not linear, then it's a parabola. So the other point is going to be there. And if you do the ridiculous stuff like, or it doesn't even draw anything. Let me see. Oh, this is already ridiculous. Of course. Completely ridiculous. Not gonna happen. I mean, this would be needed if the 4th point is on this side. Yeah, duh. take small steps. It should be on this side, somewhere in this quadrant. This is even worse because now I put it in between, and I should just suppress that. This data point comes before that one, not in the middle of 0 and 1. This is not a solution. Oh fuck. This is a solution. So yeah, so this tail should sweep through this quadrant. Then I'm happy. Maybe even this quadrant as well. No, it cannot. I mean, no, it cannot. Just this quadrant here. Yeah, it does, you know. That goes definitely through the whole quadrant there. And the rest is now no longer interesting, but we can go all the way around until this is also not interesting. Now it's interesting again because now P beta is before P0. And you see it really begins here. So this is any point in this quadrant we can choose to go through as well, if we want to. For example, say we have a point here where my mouse is. Then, well, that would be the fit. And then we go through 4 points. And the piece that we draw then is this piece between P0 and P1. That's the piece that we draw. So we have 4 data points, and then only this one is being drawn. And then for the next part, I take this data point, this data point, this data point, and the next point. And then we figure out how to roll this one. That's the intention. Right. Nice. Now, I ask myself, what happens if, say, P beta would be negative here? So down there. Is that still gonna work? I think so. But then, of course, the parabola looks like kind of like this. So then we have this quadrant where we can put something in. You can't put it in here unless you make it a cubic Bézier. This is a quadratic Bézier curve. So parabola. The cubic is an S form. So then it could go like this, and then make an S, and then I don't know, go up again, or oh, it could go like this. Here, make an S in the middle, and then go up again. So if we add a quadratic one, then we can also add this quadrant. But there is not really a reason to do that if the 4th point is in this quadrant, because you can fit a parabola. Why would you fit anything else? So I think I'm going to demand that, say, if you look at the line from P0 to P1, then the data points before and after it must sit on this half plane. I mean, of course, the whole package could be rotated. P0 and P1 could be like this, but then you want everything to be in this half plane, yeah, or everyone P beta, because P0 and P1 are like that. And then I want the next data point must be then on that half plane. And if it is on the opposite quadrant, you can you have to use a cubic Bézier. But if it is on the same side, so let's rotate back. So if it's on the same side here, then you can just draw a parabola. Although when it's on the edge, then you might wonder, you know, I mean, this would require a cubic. Why is the cubic not better? than a parabola when it is not on this side, but it is very close on this side. I'm gonna have a look at that. So we rotate around until it is. Yeah, this one. So for example, this one. It might still work because we're only going to draw this line, which is basically straight line because the next point is also there. What would a cubic Bezier curve allow me to do? I guess it would allow me to just go in like this and then make an S shape here and then go out straight. But yeah, why would you want to do that? Well, that would depend on the derivative in this point. So if the derivative is like this, a little bit downwards, then we need to make a S shape in order to end up there. In order to, well, this it must be horizontal in this point, I think, to go there. To kind of like zip. So if the data point before this point is there, yeah, then a cubic would have been better here. But then you just need yet another data point. You need even to take this data point into account in order to decide what the best cubic is. But if you put that points close enough together, then parabola is just going to be good enough. And I think I had enough mathematics for the last 2 weeks. I think I'm just going to go for the quadratic Bezier. Because I want to do machine learning and not this. I don't know. Why the hell does it take so long? Every time I think, oh, that's interesting. Let's do that. Can't take more than 3 days. 3 weeks later, not finished. Okay, so what was the next step then? The next step is to determine theta if we have a fourth point in the right quadrant, whatever. Painful, man. There is no way this can end well. Is there? The formula is already so bloody complex. And then you want me to add another point. No, no, no. Might as well include that y here. Yeah, I think I want to get rid maybe of the rotated stuff. That was a temporary thing, I suppose it was. This is X beta, has to be Y beta. No, why not? Yeah. I would still like to know what the RSW is actually. It must be this curve. So if I just calculate RSW, then I could use this. Mhm. So would that be simple, like either t or t square has this one or that one, and also for the other one, for the yt, as argument. And I dislike this one, but the rest is equally simple. RSW times something, which are anything except that one. So maybe I should look at YT. XC is simpler, maybe. So here we're calculating those things. Called LX here, I suppose. Ly looks simpler here. Like, definitely. And then which is simpler, the t or the t squared? It doesn't matter much, I think. Not at all, actually. For logical reasons. It just, that vector is, sorry, vector. How the hell do I pronounce the difference between a vector and a vector? Anyway, so the t squared has this as a vector, and t has minus this as a vector. So the argument of t and t squared are the same apart from a minus sign for the y value. And then if you look at this, so the M10 is the t argument and the M11 is the t squared argument, and they just differ exactly in a minus sign. So the RSW is super easy to calculate from that. Let's pick the t squared, whatever. So we have to take the t squared argument and then divide that by the cosine of theta. And then we have the RSW. Factor of t squared. So it's I was highlighting this, but it is this part divided by the cosine. So we just remove one cosine. Which is no longer a function of t. Just no RSW now. And then we can forget all this. Forget all the whole difficult formula suddenly is disappeared, because now I can go all the way back here and just simply define this matrix again. I don't think I'm even using xt and yt, right? Xt here, yeah, comment it out. Nothing. Same thing with yt, of course. And then therefore we are not using m either, that's just only used here. So move this down together with this, actually. Well, that kind of belongs together then. Because xt, yt is used here. So this whole part can be moved all the way down to the point where we know RSW. And then we have both theta and RSW, and then we can do the curve the usual way. I even have my V here now. Yeah. Now this one is drawn in black, and it's now drawn after the red one, so if it's on top of it, we should see it. Still. Except that there's no CG here. Okay, I'll just have to fill that in then. Cosine theta. I do have a Z or not? I have a Z. Yeah. Bang on top of each other. Or not. Fuck. I'm so disappointed. So technically other way, or what the hell is going on here? I thought that would work. Or no, it's not rotated. But what? They look very much the same. I think it's a matter of rotation. Yeah. This thing still has to be rotated. Theta anti-clockwise. Yeah. What happened? Help. World War III starting. Antwerp. Undefined behavior. Bleep. Close but no cigar. Why not? Oh, because this matrix isn't rotated. Yeah. Yeah. Okay, so I still have to rotate it? Or maybe because I rotated here and it doesn't even have to be rotated anymore. Let's make it even more simple. Please work. Yes. Yes. Beautiful. Fucking simple, except that this doesn't work. I don't know what's happening here. Must be this loop. I blame V. Well, the beauty is that the formula has suddenly become way more simple, and we found it through a mind-boggling twist of. I mean, really, I used this, right? And then we got to these formulas, and then I was like, yeah, but if I just look at the factor of the t squared, ignoring that, I can calculate RSW, and then we go back, and then we can fill it in and have it have the rotated. I mean, it's insane. It's insane. Except I want to get rid of that loop there. I think I got rid of it. Okay. Beautiful, man. So now the difficult formula is just can be removed. What the heck? Nobody cares about V anymore, right? Oh, yes, I do. But. That did give a problem at some point, though. I don't know what happened. Maybe V was not a number and then this didn't work anymore. Comparing with not a number. It's always false or something. Always true? I don't know. Let's see what I can comment out here. I don't know what this is, but I don't need it anymore. You have 0. Hopefully that whole curve can go. And then this is amazingly simple. I'm going to move the Z down then. Do we even need an A and a B anymore? Because those belong to the difficult formula. I don't seem to need them anymore. So we can comment this one out, or let's just delete everything. Evil laughter, without committing it to Git. We have the YouTube video to back up everything. I'll just watch it back and then I deleted something that I have to paste. Where? Where do we paste this? Well, before here. And I think that I don't need this anymore. The rest is plotting stuff. I'm gonna even delete this. Just going to delete it. I want to forget all those difficult formulas. Never a need for it. Now we have a rotating parabola that goes through 3 points, and it is parameterized and has a simple formula. Fuck yeah. I think you can do a PhD about this. Some people are really, they write a PhD, they write a thesis on a topic like this. I have to do one more point though, and then we can write a thesis about it. Nah, maybe not a thesis, but a paper, definitely. Publishable paper. Okay, let's see. Yeah, it's shocking, but I feel like I wasted my time deleting this. They're going to tell me that we can even simplify this further or not. Not really, right? Y times a cosine of theta. And this is y times a sine. Can ask Mathematica to look at it. You can simplify this. Let's write a bloody script that I can paste stuff like this in, and then it comes out as Mathematica formulas. Because I'm getting tired of this. We have ChatGPT to do that. Just start with please, and then it will do it. Please write a script that I can paste in C++ code like example, and then get out Mathematica definitions. By doing the following. 1, replace, no, for each, well, remove the double. 2, replace with 3. We're going to put this in front of it because something in front of it. Add a line with symbol name x beta, etc. for each variable used, but not the ones we will define with, of course. Now it's going to be going to need to be very smart to understand this. What's the next thing? No, that's about it. So replace standard sine, standard cosine, and standard tan with sine, etc. Do your thing, AI. It's all happy doing Python. It can do Python best. Example usage. Yeah, no, I wanted to read from standard in. Yeah, write it all again, bitch. I mean, I really don't want to abuse ChatGPT, but it does it itself. It just rewrites everything. I can't help it. In fact, I have in my custom things that should not repeat stuff. It does it anyway. Well, custom instructions don't work at all. Let's see if this works. Do mathematica.python. Whoop. And then I guess change mod plus executable. And copy this. And then echo quote paste. That's so not going to work, of course, but hey. Trust in ChatGPT. Nothing happens. Oh, yeah, ChatGPT just took over my PC because I can't even Control C this thing. Yeah, what happened? Syntax error near unexpected. Okay. Let's. Oh. Let's cut it some slack and do it like this. Just hangs. It hangs. It takes my mouse or something like that. So totally not working. Control D. To end with Control D. Oh, I would think that This is the same channel as ASD. Nothing. Nope. No, disappointed. It's not working. Thanks. Without output. And seems to grab my mouse. My mouse, which changes shape to something that looks like rectangle select thingy or something. Oh, it did not. Wow, that's yeah. Okay. 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 I thought that it was already there. I mean, I don't know Python. How should I have run it otherwise? Everyone is to blame except me. I mean, yeah, that was missing. Try to remember it for next time. Okay, that was it, but nope. Let's try this one. Much better, but yeah, still no square brackets. Better, but please remove indentation and empty lines, and it should be sign X, not sign X. Note the square brackets, Mathematica and stuff, and repeat the whole script. Repeat it all from the beginning, not just the lines that changed. No, everything, including the shebang. Yeah, there we go. I didn't know I could hear my microphone. Well, you better get a road, ChatGPT, or some ChatGPT banging will happen. We still have to do this. One GDGI paste, tick tick doing bling, and there we are. That's okay. Yeah, that's what we wanted. I didn't remove the semicolons. How stupid is this thing? One last thing. It does it all again and again and again and again. Now we wait for it. Now reserved words are suddenly STD. I don't know why, but it apparently thinks that double colons are... okay, no, actually that makes sense. It doesn't want to use STD as a variable name. But, I don't know. I don't know. I don't know. I don't know. Right. No, that looks good. So now we can copy this, as lazy as we are, and paste it into holy Mathematica. Why do I have so many? Kill. What is this? Compart.com. Oh, that, sorry. Yeah. Nah, that can go. That can go. This can go. That can go. This can go. They were very happy with that page, that site. No. That still works. Amazing. Symbol name argument X beta acquisition one is expected to be a symbol. You cannot use underscores. Fuck. Let's go back to Daddy ChatGPT. Mathematica doesn't allow underscores in symbol names, not even if you tell it that it is a symbol. You think that dollars are accepted? Dollars. Okay, most people accept dollars, but if Mathematica accepts it, I'm not so sure. Looks like totally not a real variable name to me. Although it is replaced with a blue thingy. New argument is expected to be a symbol. Oh, fuck it. Not that again. Clear all. Symbol. What? Why would that be still? Let's see what I did. I just removed it completely, which might be a better idea than using a dollar. Damn it, I told her not to do that. The script is still wrong. There is another issue. I told you not to use symbol name for variables that we define with but symbol name or is W and Z, right? Yeah. Or is W and symbol name Z is are outputted. did not work. Now you're gonna say I can manually remove them, but yeah. Oh no, AIs are going to replace all programmers' jobs soon. TM. And then the economy of the whole world will collapse and we will go back to the Middle Ages because nothing will work anymore. Here's the updated script, blah 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 blah. Here's the updated script. Okay, whatever. I'll just take the last one, if you don't mind. Now, if it wasn't Python but C++, I could just fix it. I think I got it correctly. It finally got it correctly. At this input anyway. Ding. Yeah, let's delete that and everything below it. And I don't know how to do that, but I'll just do it anyway. And then we paste in this stuff. No errors, unbelievable. Okay, and what did I want to do again? Simplify, as if that is working. Okay, so what do you do? Simplify, and then I want to simplify. Well, RSW. Okay, that was a waste of time, clearly. Is this the best it can do? Yeah. If I do, okay, hold on. The output is now correct, namely if then I type simplify or SW. It does Mathematica is not using Z. Is it possible to make it use Z to simplify things? Hmm. That does not work. Yeah, I think you have to. I think the problem is I already defined it. So maybe I should not define it then. Let's say I remove this line. And then we repeat this. And then we repeat this one. Nope. Still nothing. It already knows this one. It's a semicolon doing that anyway. Come on. Still nothing. Random attempts. No. I think the width works, but the simplified is oh, even that doesn't work. Oh, nah, it's the other way around. Fuck. I'm blind. Yeah, it just says so. It just replaces it, man. So this is exactly the other way around. It just replaces Z with that. I want it the other way around. I doubt it. Doubt it very much. Yeah. Nope. No, I give up. Not worth it anymore. Spend a half an hour on it, if not an hour. Manual simplification coming up. Oh wait, we're already there. Yeah, I was thinking about the productivity increase that ChatGPT gives me. So, Manual. Yeah, I hate to do this, but it seems shorter. Divide z by cosine theta. Nah, it's hardly worth it, is it? I don't know. Tangents. And then this can be removed. Because of that one, but now because we divided this by cosine theta, and therefore that can be divided. But now we divided that one as well, so we have to multiply that with cosine theta again. So let's multiply this with cosine theta, and then we multiply the z, but then this can be, which is 1. And then you would almost think that maybe I should, yeah, I probably should, to undo. Oh, not that much. Believe in that. On, on. Copy this in the mouse buffer, and then redo. And then let's remember what I just screwed up, changed, I mean. And now we're dividing by z minus 1, but I think we did that already anyway. Plus, why would z ever become 1? Or 0? Oh yeah. Oh man, now it looks completely saying this. So it goes on not on what? Why bad eyes? The point being that now this is simplified, because I'm dividing by cosine theta here, and then multiplying with it again. It looks like the whole matrix is just simplified if I replace it directly in it. Let's first check if it didn't make a mistake. Oh, it's a very idea. Well, I keep checking myself, because you never know. Oh God, chat. No, I'm not gonna go through the history of ChatGPT failures again. Oh no, it still works. Did I blip? Yeah, then this is actually the same as, I need a new variable, I think. Like double, dude, it's Q, no, R, no, think of something. ZZ. Oh, ik might well use foo. G. Did I not use G already? How is that possible? I don't want to use G here. Shit. Thing must have a meaning there. No, think about it. It's just M11. I will begin with M11. Double M11 equals, and then we define M11 because that is RSW times the cosine. Yep, so that is that, my friends. My God, so simple. Forget the paper. It's not going to be accepted anymore. Okay, that was it. Yeah, and then this one is negative that. And then we have this one is the sine instead of the cosine. So actually, yeah, we just have to multiply it with the tangents. Yeah, it is this one times the standard thing, but can't make anything else of it. And this is then that minus this. And then we don't need this anymore. And I just did it already. Yeah, no Mathematica could beat that. Simplify my ass. Only annoyed by the fact that I have twice a tangents. How do you tangens in English? In Dutch. What the hell is that in English? Tangent? Maybe it's a tangent. Or something like that. So yeah, I multiply M1 with the tangent, which is actually just this, just minus that, so it's just that, which is something that was divided by Z. Which then already and Z minus 1, by the way, let's just talk about this Z. Beat the Dutch words, the tangens. We call this tangens, and the other things, this one is a sinus, and this is a cosinus. That's a tangens. Tangens, yep. The tangens of theta. What shall we do with that tangent or something? I don't know. Nothing. Everything weird. I'm just going to erase my whole history. Nobody knows how we got this. It's really completely out of the blue. Who cares that it took pages of mathematical formulas that then we simplified to get this. Right, okay, next step. I guess I used beta because the beta is like a B of the B of before. So I guess now I should use the A of after, alpha. Let's define an alpha in the end. I'm gonna use the alpha, P alpha, to also determine theta. And then with the theta gone, we have a matrix that is entirely determined by the 4 points. It's taking forever, man. But there is progress. I'm here. I want to go to a subscript of alpha. Well, beta existed, didn't it? Uh-oh. Really? Oh, yeah. Yeah. Beta existed. Alpha, not so much. Yeah, well, pick one. I'll use row. Because it's free. I'm never going to use row. Anything else? Though a row really looks like a density to me. As a physicist. Maybe anything better here? Why they don't have a subscript alpha is absolutely beyond me. Why have beta and not alpha? This is pure racism, I wanted to say, but of course you cannot make that joke because I don't know why, actually. The word is overused. That's a problem. It's not even funny anymore. Gamma, maybe? Phi? Bullshit. Xi? I don't know. Nothing works. Okay, I'm gonna go. Let's try the gamma then. Oh, it really looks weird. Gamma. So the omega would be nice. As in after. Alpha and omega. You don't have an omega. It's a really sad story, this subscript list. Why the sad face? I'll be my new. Okay, so this is larger than T1. And I'm going to use, therefore, something larger than 1. And, yeah. And something, I don't know, something difficult. But larger than, also larger than 0, just like that one. And then we have to call it gamma. Gamma. And then we have to copy this. Because we like code duplication. And then I have to replace this with the gamma. And then the whole rotated thing can be removed, I think. No longer doing that at all. Let's first compile it and run it. There's my gamma here. Yep. So now we need to automatically have this curve here go through that one as well. And then I'm almost done with the Bézier. Only 2 more weeks and then I'm done. We're almost there. Ish. What shall I do? What shall we do? What shall we do? The gamma has been plotted, but almost off my screen. That's okay. No, it's not okay. I'm gonna make this 1.8. And I'm going to get rid of the rotated. So, rotated underscore. Keep your code clean. So no more rotated P1 because we just use P1. And here's another rotated. We're going to replace that with P beta simply. Yeah, just all those rotated things can be removed. The whole line removed. The prefix removed. And that was it. Make. No errors. Run. No errors. And nothing changed. It should actually be like so, you know, kind of, yeah. The previous one's better. How are we going to achieve that? Well, this means, of course, that the xt and yt are equal to the new points. So, new math. The x of the gamma is going to be equal to afraid I have to get rid of all of this. T times m0, which is 1, sorry, 1 minus m01, which is m10, really? Which is minus m11, which is, okay, so Yeah, just gonna start a new one. Probably have to copy it again. What the hell? Keep doing that. XT. Let me just define XT as that. And YT as that. And then I mean that. And then we can look at it. All right. Absolutely no reason whatsoever, I think, to talk about the tangents here, because it's just another variable now. I'm going to call this symbol name Tom. JetTTP. Unbelievable. You have to do everything yourself. So the tangents of theta, that's my symbol. And then we go here, TT. And here, TT. And then do all of that. And then probably do these again. And then look at this. Okay. TIY better. But, well, we know what we mean. Let me think here. What I wanted to do is... You want to solve the tangents of theta, aka TT, from... Why the hell do I have two equations? Oh, I also have a t. I have to get rid of the t then. Oh, painful stuff. Yeah. Very painful stuff. It's getting too late to think clearly. I think I'm going to go take a bathroom break and then I'll try this. Try to enforce my will on mathematics. Yeah. Yeah. Anyhow, I'm coughing this. Let me think about this. Yeah, I think I have to solve T from both. And I have to get rid of T. And that would be a solve then. Solve. And then we have... I'm just gonna use a single character maybe. Or I could type full out x comma equals xt. Solve for t. Oh yeah, easy. Always forget to assign that to something. Because we got two solutions. This is just t solve from x, right? So it's solutions of t for x. I'm gonna call it x solves. And then you have to do the same thing for y, the y solutions. Is solve y gamma equals yt. So for t. Yeah. Also monstrous annoying that there are two solutions. I think I've been here before and it didn't work out. Although I got a few nice plots. So in the end I did it differently. I rotated stuff so that the corolla is upright and then solved it and then rotated it back and that worked. Do we have to do that again? Maybe we have to do that again because this is not going anywhere it seems. Let's just try. No, it is not working. So it's really not working. But solve, you know, x solves big one. That's the horror with the solutions. Why having two solutions? I mean, we have four different equations, and probably even that isn't very nice. And I want to solve theta from that. It's gonna complain. I know it. Oh, empty. Oh, that's a lame complaint. Really? Does this mean I can't find it, or what? I just deleted my rotated. Now I have to add it back. I think I'm gonna do that tomorrow. If that's necessary. Yeah, how much simpler do you want to have it, man, than this? And then 2 steps later we have this. Ridiculous. Okay, let's define a function instead. So yeah, I'm having function. What is it? It's t solved. I'm gonna say solved, and there was an X in it. So just whatever. And then I'm guessing we have a theta. That's about it. No, I'm having a T. Sorry, I don't have a theta. I have a TT, but we also have a T. Still, the T equals that then is equal to T with X sols 1. Let's just make the whole list. Why not? So this is 1. Now we do that again. SXT2 TT underscore comma T underscore is T with slash dot X sols 2, and then SY T1 T underscore comma T underscore is T. Solution of Y sols 1 SY T2 is GT comma T underscore is T slash dot Y sols 2. Okay. I'll try to solve again. Solve. No, but I'll do something stupid here. Set it equal to T. Why did it set it equal to T? What is T? Sorry, yeah, this is T. I just don't get why I added a T underscore here. Is that then required? The result is not depending on T anymore. Let's try to remove it. Yeah, seems to have worked. And then we want to try solving setting, let's say x as xt1 tt equal to as yt1 tt, and then solve for tt. Insane. It actually gives me something. Now, there's the answer then. Except I get 2 answers for this solution, and we have four different ways to combine these things. 1, 1, 1, 2, 2, 1, and 2, 2. So I have 8 solutions. And only 1 can be correct. Guess I'll have to draw all of them and then see which one is the correct one. Yeah. So the next question is then, can we draw this? Let's call this thing simply solutions. And then I want to draw something. But what? TT. Basically, I want to draw my parametric curve using this TT. Parametric curve would be this one, XTYT, where T is just, yeah, T is the parametric thing, and M0 and M1 are defined all in each other and in DT, and the rest. I do have to give values probably then for x beta and y beta and x comma and y comma. It's a part here. Oh, you can hard code it in. Find that a bit scary to do, but yeah, I think it's time to let go of the variables and just fill them in. X beta. It's defined as, well, not defined, but is from now on has a value. Minus 0.5. And y beta is 0.25. And x gamma is 1.8. And y gamma is 0.2515. And that's all. Yeah. The other 2 points are 0, 0 and 1, 0, but they're like hard coded in the formula. So with these values, I want to do a parametric plot. Yeah, I forgot how that works. of two functions, namely xt and yt. Yeah, that's these things here. Where t is the parameter, so we're going to run t as usual from just I don't know, minus 40. Should we go to 40? Yeah, don't know, but it has these values and t. It does not have tt. Can I do a slash dot here now to give it the tt? I suppose so. I think so. So slash dot source. Only I'll pick the first one. So when you have the first one here and the first one here, and then whatever comes out of that, take the first one of that. I would be surprised if this works. But who knows? Shift, enter. And we have a graph, empty graph. Doesn't even tell you why. It's very suspicious that xt has a color and yt doesn't. Ridiculous. Let's see, it still knows what xt is. Xt is, yeah, well, it's a function of t and tt. The rest is filled in. And yt also. Maybe I should use a width or something. Yeah, I have the feeling that maybe I should do something like define my own xt function and then give it a parameter and then define that as, I mean, you can only do the slash dot here basically, so that is then the xt slash dot sols 1. Oops, that was not what I wanted. Return, and then we have the xt, sorry, the yt function of tt is yt slash dot sols 1. Yeah, these things are also a function of t, so probably just add them here. I'm really just winging it, man. And then we can do the F here, and then I say T, comma T. To go back to actually using them. No, wait, it's not possible. Wait a minute. Answer X to the solution replaces TT. This is only a function of T now. That's what I want, of course. So then here I can just pass T. And then of course that must be my function. And then you don't have the source here. Well, that looks horrible. You call this a plot? It's something very wide and not as high. Let's try 4. Yeah, the 40 is bullshit. Of course. Oh, it's still flat. Can't scroll. So the next step is to just plot all 8 of them. And then hope that one of them looks sane. I don't think this looks sane. Even the -6 is still a lot though. I'd like to know what the vertical value is. It's not giving an error though. Let's call this one 1, 1. And then we have 1, 2. And nobody knows why I did that, because now I have to change even more. 2, 1, 2, 1, and 2, 2. It's not happy. Why are these things now empty again? I probably have to start over. Which part of clear all did it not get? Apparently the clear all is not clearing all. At least I don't think so. Whoops. I vaguely remember that you have to put a dot behind it though. Let's try this one. That's not complaining, is it? Oh, then we can do this. Shift Enter. Oh, we can delete this because we are self-secure. And then we have the X source and the Y source. Let's do those again. And then you have to define, what is this? Solve. I think I have to delete this too. Yeah, it was just empty. Now let's try this one again. That also works. And now hopefully this works. Because otherwise I don't know anymore. Now it works. Thank God. And then we can do this again. But now I'm going to use, let me see. Now we have souls, now we have 4 souls and each have 2 things. So let's call this 111, which is then 1111, and then I repeat that. And then that's the second solution, which is then 2 here. And as such, we have a lot of them. Enter, paste. I'll go to, let's say, 2 here. And 2 here, and 2 here, and 2 here. And then copy that. Return, paste, then we make it 2 here, and a 2 here, and a 2 here, and a 2 here, and then we check if it, the 112, someone, just quick, 121. 122, yep, okay, so now we copy all of that. We buy a new mouse and then we copy all of it. Control C, return, Control V, and then hard work. How to edit Mathematica notebooks. Okay, let's sort it there. 2. Doesn't want to go down. That key, delete. Down, that one, yeah, and the last one, and then check it again. Well, 4 of those, and the rest I didn't even change, so that should totally work. Yep. And the parametric plot, still have that here. We can plot several parametric curves. So I just should put another brace around it here. Oh, what happened? Don't tell. Oh, okay. No, never mind. And then when I click there, we move everything up just to give them a heart attack. Yeah, and then 8 of those, right? Okay, let's do first this. Pop, pop, pop. Top, top, top. And then control. No, copy that. Oh, copy it including comma. Let's do 3, 4, 5, 6, 7, 8. Imagine that it doesn't work after all this editing. That would be horrible. Yep. What are you doing there, one? There's ones. Once they were useful. Enter shift. And one of them survived. Or maybe more. I don't know. But we don't know which one. I can just tell you that this thing is going through 0, 0 and to 1, 0. And what were the other points? I have that here. I really should have that here somewhere. Yeah. Minus a half, a quarter. That's 1. This is minus a half. There is the point. That is a quarter. What a motherfucker. This is unbelievable. You know, you're just typing half an hour, doing stuff like this. You hit enter, and it just works. It just keeps working. And I was number 1 at my local club today as well. Yeah, I'm a winner. Yeah, I did really well today. I had a not that good partner. This can you look that up? I'm gonna show you guys. So I'm doing whose ball? Yeah, this with old people. That's me. So we throw balls from these things are 8 meters long and 2 meters wide. And then you throw a ball, and you have a white ball here. And then in the end, it's about who's closest to the white ball. So in this case, yellow is very happy because it probably has 3 balls closest. And this one is then maybe a little bit further than that black one. So that one doesn't count anymore. So and you play with 2 people. So my partner was throwing a lot of balls just out of the of the mat. But yeah, we got 29 points in total. And then I think the number 2 had 26. Yeah, it's a fun game. Almost as fun as this. No, this is way more fun, of course. But the big drum ruffle is, of course, the other point here, because that would be new. We have a 1.8 and almost nothing, 0.15. 1.8, no, let's start with the 0.15. That is like there. Yeah, yeah. Yes, okay. Now the question is, which one is this and why is it that one? Is it maybe sometimes another one? Because. No, there can only be one. But yeah, maybe sometimes they switch. I'm not sure. This is scary business. And how do you find out which this color is? Doesn't even say that. That is super lame. Let me think here. How can we find it out? I could just delete everything one by one, or do a binary search and delete half of it. But then I have to paste it in again afterwards. Or I can just copy it. Oops. Control C and then paste it. And then do the binary search. Let's start with deleting the last half. That would be all of those. Oh, there's a comma at the end, which didn't complain about. Something like that. Shift. That still contains it. Got a different color for some reason, but we're gonna delete that. Ew. I deleted 4 of them, and now I'm deleting 2 of them. Shift. Oh, it's still there. Jesus. Now it wasn't the first one, so it has to be that one then. Let's kill this one. And then can you remove an extra brace? Yep. 112. No. One 112 means that it's this one. That had to be 112, of course. That wasn't a 666, so what can you do? You're just a mathematical variable. Right, so it's sols 1 and then the second one. Sols 1. That's the top one and then the second one. So this is the bottom here. Is the answer ish, yeah. Kind of, I guess. And then I have to type that over to C++. No. I wish only that copy to clipboard was possible. It's not possible. You can click what you want. Let me see if I see a pattern in here. Y gamma minus Y beta. See that more often? I see it here again. Not super often. Here's no. Yeah, I think it's again here as well. This could be super simplified. Maybe I should try that. Simplify it. Oh yeah. So we need this is the second one of the first. So this sols 1, 2. Oh yeah, I did. Should I just try to simplify this? XDF. Simplify XDF 112. No. Nope. Okay, what about T, right? I think T is still verbal. Yeah, no, that's not what I meant. Okay, so we have to remove all those definitions again here. Let's try that one, and then I'm gonna copy this. Probably have to redo whatever we did after that, so do that again, but not what has been done above that. We paste that here, make this a dot to erase the values. And then we want to redo the 112 one. Did I do that on purpose? I think so. Shift return. Okay. And then we want to do this, I think. Or try it anyway. You have to do Control C. Interesting. I'd never heard of vertical scroll, Mathematica. No, I think it's this thing. Oh, even that not. Dude. It's a good thing I have multiple monitors. Oh my god. Yep, 2 monitors is not enough. 3 monitors. No, 3 monitors is not enough. That's a big formula. Oh, wait. It's scrolling. Awesome. Yeah, now I can type all day. From left to right. I can probably also scroll while this is just on one monitor, right? Let's try that. There's one back. And the other. And then fit it to the OBS again. This thing. Oh, there we are at the end. No problem. And just so you know it, this is the output of Simplify. Try harder. Try much harder. Nope. Feels shorter. This is really sucking. I don't mind that a formula is this big, but I have to type it over. Why does this start with 1 point? How on earth? Well, you ask for a simplify and then it has factors of 1 in it? Maybe these things are actually, 1.0005, and I will never know because it doesn't show me. I have a 4 and then an 8. A lot of square roots. I'm pretty sure it's a 1, but it's ridiculous that the simplifier is not removing them. Maybe it's code for this is a real number. Yeah. Jesus Christ. I click on this and then just nothing. It goes away. Advanced social expression. Nothing happens. Very advanced. Convert to traditional form. Seems like it doesn't matter what I click, it just doesn't do anything. Right click doesn't also do nothing. Did that change something? No, not really. Yeah, I think it changed it a little bit. Okay, trick, you click on, you do right click, input right click, and then you change your mind and do a left click, and then you hold it and then you let it go, and then it does something. And now we have an output that we can do something with. Where's my square root? Yeah, square root. Yeah, that's what we were looking for, I think. Except there's still still have to copy this. Hopefully now, like that. Copy. I'm not sure. Let's try this. Copy, paste. Yes! Yes! You got it. Can I already go to bed? Please let me go to bed. It's bedtime, right? Yes, bedtime. Okay. I don't know what to do with this, but like that, it's the comments. Yeah. Okay, let's see if we can impress ChatGPT. Mathematica. gives me the following formula. Dot dot dot. Boing. No idea why he put one dot in there, because this is the output. Oh, simplify. Anyhow, can you please find common patterns, or what is it? Is terms, factors, function, no. Formulas, expressions. Common expressions in it. And convert this to C++, like where you know, first some variables are defined and which then are reused such that the total code size is minimal. Sure, no problem. Sub-expressions. Yeah, I wanted to say that, but what the hell is it doing? That's a lot of common expressions, something. Yeah, you're failing me again, as usual. Continue break. No, I was asking you to do that. Bloody hell. A tool. A tool like what, man? So yeah, that just lets me down. I'll have to do it manually. Apparently. I don't want to lose this, so I'm gonna copy it. I mean, it's also in Mathematica still, but yeah. That's my expression, and I want to replace substitute one dot with, wait, one dot star. Is this ever followed by anything but a star? Yep. I do not want to remove that. That's just a +1. So let's say I want to remove one dot star with 1. I have to see them all. Wait a minute. So 1 times No, no, or nothing. Get rid of the 1. Next is gee, I have a bugger of 3 here. Look for all the nothing. No. Squares, 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 lots of squares, and 2 power 3s. And the square is applied to y beta and y gamma, even x gamma, and an x beta, so basically to everything. Okay. Well, definitely could begin with the common expressions for that. So we do double. Now we begin with beta, begin with x. 2 is x beta times x beta, and then y, and then double x gamma 2 is x gamma times x gamma, and the same for y. And then here I do substitute. I can just do this. Yep. And then we have 3 here. Y gamma and y beta. Okay. It's just the y. Sure, that's just a 3. Is y beta 2 times y beta, and then we have here and y gamma 3, which is y gamma 2 times y gamma. And then we do here and substitute of 3 with 3, and there's another one. Then let's have a look at all the square braces that we have. Not even that much. Square root, square root, square root, square root, square root. Yeah, of course, there's no sign anymore. Or anything. So I guess I can just, yeah, they have matching braces and everything. But let's separate these things on a different line. So we have a square root here, which then ends there. And then we have a square root here, which ends there, which is suspiciously the same. And we have a square root here, which ends there. And a square root here, which ends there. Oh, I love this. Definitely common square roots there. Square roots. No, I had expected that. I looked at the formula and I thought, all those square roots are the same. Yep, but are they? Well, we are very lazy, so what we do is the square root. And then and then hope that indeed they all highlight, because otherwise this is a waste of time. Did I miss another slash? I don't think so. Dot star dot star. Wait, I have to do these as well? Not even sure. No, I shouldn't. Bing. Oh no, wait, there's one more. Ding. Still nothing. Shit. Did I forget something? Oh no, I just have to hit return. Wait. Return? Nah. And all of them are highlighted, so they are all exactly the same. Whew. Okay, so let's call that the square root expression. Which is equal to whoop. And then seriously about my spaces. I need my space. I like to do that for some reason. Plus better. Maybe this is also has also common expressions though, but well, we'll see. Comma divided by oops, plus 0 star. Maybe I should have used a formatter here, but I normally don't use formatters, so I don't know how to do that. There's a Clang format or something, which maybe could have used. Good. Plus, I want to split the line out because it's a bit big. I'm gonna have a few other highlights here. Definitely different. 8 also, yeah, looks like nothing is repeated in here. Well, this is the square root of what is this? Square root of that. No. Yeah, I don't know. Hmm. Это. Это... Oh, tea. No. What is the tea doing here? Oh shit. Impossible, of course. I would not have been able to plot it. This majorly sucks. What? No way. There's a fucking T here. This T. It's here. No. No. How? Why? Is this thing a function of T? No. No. XD sol T. What? So I'm plotting this thing and then I'm plotting it. Just fill in T here. Something must have gone wrong here then. No, there's a T here. One T. Okay, so that looks like it interpreted one of these T's as a T. Ridiculous. Is that even possible? Oh, there's a T here as well. T times 1 plus. Yeah, the T did not get resolved. Yeah. It's a T from the XT. This is XT. No, it used multiple lines for some reason. It's just this T up front, and then that T we see as well. That should not have happened. Pretty confusing. Or should it, you know, because Yeah, okay. No, wait a minute. I think I'm getting it. It's not TT. It's XT, which is a function of T. I can still continue, I guess, and then plot it to see if the formula is correct. And then you can do maybe the same trick. You just look at you already see it coming. You know, these things are just equal. This part and that part. So yeah. You have a in the end, I can, I think, derive again from this formula what the TT is then, which is then probably one of these or something. And then, of course, we have theta. Don't even need theta, maybe. Just well, maybe I need. No, I just need tangents of theta. So having TT is good enough. Yeah, okay. No, I thought something went wrong, but it is just it's indeed something else. But yeah, I think I'm going to go to bed and then try again tomorrow because there must be a better way to convert this monster formula to C++. Pretty much repeat it. Yeah, I know, and we have two of those also. I mean, come on. We need to find a way to automate it. All the square roots are the same, so that's makes it a lot easier. Yep, bedtime. But I have a good feeling about it. This is just going to work. And once I have converted it, it's probably also not that much, you know, just lots of duplicated stuff. So you just calculate a part of it and then you have almost everything. People, good night, and I'll be back tomorrow. Thank you for keeping